Okay, so this is the first layer 3 VPN and we're in chapter 5. Now what we've done on the diagram here is all of the customers C1, C2, C3 and the external peers and the internet exchange we've coloured in purple. And the reason is they're part of that internal aggregate route or they're BGP connected, but they're nothing to do with the layer 3, layer 2 processes. Now the customers that begin CE1, CE2 and CE3 are now coloured. So we're doing CE1, it's an OSPF layer 3 VPN, and you can see it here on the board in green at the following locations. Okay, so the first thing you have to do is get the route reflector ready to carry layer 3 VPNs, set protocol BGP group, cluster 1, family INET VPN, unicast. And we're going to put that on cluster 2 as well. And then when we specify INET VPN, we then have to specify INET unicast because it's implicit until we specify another family, and then we have to re-enter it. Otherwise, we'll have effectively turned off INET unicast and we'll have all sorts of trouble. Now, the route reflector is not in the it's in the signaling plane, but not in the data plane. So therefore, it doesn't have an INET 3. And as the routes come in on layer 3 BGP, we're wanting to resolve them by looking in the INET 3. It's not going to be possible. And so what will happen is the route reflector will stop reflecting those routes. So we need a static route in here. So routing options rib, INET 3, static route, 172.16.5.0/24 receive. Now, you could even be discarding at this point. What will happen is the route reflector will see that the route is resolvable. It will see it as a possibility. It will send it out through BGP. So it's staying off the data plane, but it really does need some sort of static route for the loopbacks here. Okay, so let's have a look at router 3. We're taking the interface live. Then we're going on to the BGP. We're also putting on the same families. And then here we're doing the first of the really key points. We're giving this routing instance its own unique loopback. We're going to be using that in a moment for some Sham-links. So that's really important. Then we go into routing options and we do route distinguisher ID. So this particular VPN, we're going to have a PE unique route distinguisher. We type in route distinguisher ID. We put on our own loopback. It will create the IDs, and it will allow us actually to load share because the routes will be in the table demarked by the router ID, the route distinguisher ID, and if that's PE unique, then you can have one or two routes from different customer connections, different PEs, and you can load share and you can choose between the routes. So route distinguisher ID, not only is it useful and easy to use, but it has an advantage for load sharing. Okay, let's go into our routing instance. Set routing instance, shortened it here. C1 instance type VRF. In goes the loopback. In goes the interface. And then on goes the OSPF. So C1 protocols, OSPF, area 0, interface all. And the customers that connected in here has really no idea they're connected into a VRF. They see it as just a standard OSPF interface. Of course, we have our target. We're not using VRF import and import on this case, import and export. We're just using a standard target. So it's going to automatically push these routes into the BGP L3 VPN for us, scan the table and pull them back when they appear. Okay, so let's have a look at our customer. Now we've been told that there's a backdoor link between C12 and 13, but obviously the customer sees that as their backbone because this is clearly in one site. Now the traffic pattern that we would like would be that the customer preferred the BGP MPLS for traffic between the sites and didn't use any backdoor links. But obviously from site to site, we don't want the traffic coming into and out of the BGP L3 VPN. Okay, so how are we going to do that? Well, unfortunately, OSPF has a problem with BGP L3 VPNs. The traffic goes in, the route traffic goes in as LSA 1s and 2s. However, it appears on the other side as LSA 3s. And for OSPF, this is an issue because OSPF will always prefer to stay in its backbone if it can. And when it sees the LSA 3, it thinks it's an inter-area route rather than intra-area route. Consequently, it will naturally search out any backdoor links that may be possible. So the way that we're going to fix this is with a sham link. Now, the sham link fixes this because what happens is the LSA 1s and 2s go in as LSA 1s and 2s and they come out as LSA 1s and 2s. Okay, so this is very, very similar to a virtual link, works in a very, very similar way. It's slightly more virtual than a virtual link, and here's how we configure them. So here we are on router 3, set routing instance C1, protocols OSPF, Sham-link local, and we're using the specific loopback that we've put in this VRF. And then OSPF area 0, because this is where the Sham-link lives, Sham-link remote, and we put in the IP address of the peers, this one, and this one. Now, we really don't want traffic going up to the BGP L3VPN and then down again to get from one end of the site to the other. And so we're putting a metric of 100 on router 3's Sham-link, and then down on router 4, we're putting a metric of 100 on its Sham-link to router 3. And then this will normalize these LSAs. They're going to be coming in as 1s and 2s. They'll be staying as 1s and 2s. The traffic will prefer within the site to stay within the site, and between the areas, it will go over the BGP L3VPN. Finally, you can actually see these Sham-links. So if you were to type, for example, run show OSPF neighbor instance C1, you would actually see these Sham-links connected as neighbors to this instance.